33.4. This video we're going to from the perspective of breaking and forming of bonds to know why reactions can be exothermic or endothermic. So last video we talked about when atoms come close together, when they're going to form bond, energy will be released in the process, and that will bring up a exothermic process. And then when atoms are separate apart, okay, you're going to break bonds, and in process you require energy to overcome the attractions. So therefore that will be a endothermic process. So that is the basic concept, okay, for this video. First we can have a look of these examples. So when we have H2 react with the oxygen and then form water, this is a combustion of hydrogen. Okay, we learned it before. Combustion of hydrogen is an exothermic reaction because it's combustion process, heat is releasing. But what actually we are doing, okay, in this process? So if we draw the hydrogen, oxygen, okay, in a structural formula, okay, molecular state like this, we can realize that there are two hydrogen molecules, and each of them will have one single hydrogen covalent bond like this, okay, while between the oxygen atoms there is a double covalent bond here. Okay, so remember in these sections, okay, you have to illustrate the single bond and double bond clearly, because single bond and double bond, they require different amount of energy to overcome that. Okay, so in order for it to become H2O, first of all, okay, we have to overcome these covalent bond. So we are going to break two hydrogen single covalent bond and then one oxygen doubled covalent bond. After we're breaking all this bonding, we're going to break these two hydrogen bond and one oxygen double covalent bond. So because this is a bond breaking process, it will be an endothermic endothermic process. And then after that, okay, they will become atom. And the next step, okay, we're going to form, okay, this OH bond. Because we are forming two water molecules, so in total, okay, we will have 4 OH bond. So therefore, formation, we're going to form 4 OH bond. We have to count it to them. And in this process, because for bond forming, it is an exothermic process. Okay, so this is how we have a reaction to occur. Actually, it will involve a bond breaking to break the reactants, and then breaking them down into atoms, and then with a bond forming process to form the products. So if we put them into an enthalpy level diagram, you'll see something like this. At the beginning, the reactant just random one positions. So you see that we have H2 and O2. Because we are bond breaking, so we will draw it going up. Okay, so we absorb energy and then break them into atom. So this time, okay, we will break them into atoms. So in total, there will be 4 hydrogen atoms. So we put 4H, and then we have 2 oxygen atoms. We put 2O, and then in the process, they will have a bond forming 2 H2O. So this one, bond forming, how low you have to go, okay, it will be relative to the bond breaking. If you release more energy, it will go lower than the original level. But if you release less energy, then it will be higher than the original level. Then the ultimate process, okay, it will be exothermic and endothermic. It depends on the difference right here, okay. So in this case, the bond forming, the energy release is more than the bond breaking. So you see that the level go down, okay, lower than the original position. So you find that the reactant is a larger value, product is a smaller value. Product is lower than the reactant. So product is smaller value, reactant is larger value. So this delta H, the delta H will equals to a negative value, and this is an exothermic reaction. Okay, so in the process, actually we are having the bond energy change in bond breaking, how much energy you absorb, and then minus how much energy you're going to release in the process. If it is a negative value, then that will be an exothermic reaction. So same thing happened in the endothermic reaction. First of all, we have to overcome, okay, the bonding, okay, in ammonia in the reactant. So in this case, we have 1, 2, 3, 4, 5, 6. You have 6 NH single bond to overcome. In other words, okay, you're going to bond form and you form N2 and H2. Remember, N2, we are having a triple bond here. So therefore, you're going to form 1 N triple bond and 3 HH single bond. So this one is exothermic, okay, and then bond breaking is an endothermic process. So enthalpy level diagram, first of all, we're going to absorb energy to break the bond at a higher level, become atom. And this time, okay, when they form bonding, okay, form N2 and H2. If the bond formation process, okay, is less energy than the bond breaking, then you will see that it will fall in the middle between the reactant and also the excited atom state, or will be somewhere in the middle. So in this case, okay, the product have a larger value than the reactant. So therefore, this delta H will then be a positive value, which is an endothermic reaction. So for endothermic reaction, as we have said before, more exothermic, more negative, the reaction will be more visible. So if this one is endothermic, in general, you require absorb energy from surrounding. That means you have to provide energy to it in order to process these reactions. So it's less likely to have reactions naturally in the environments. Okay, so let's have a look of a class practice. So right here, okay, we're having ethene to form hydrogen chloride, okay, and we know that that will be an delta H smaller than 0. That means it is a negative value. It is an exothermic reaction. So state the covalent bonds that are broken and that are formed in this reaction. So first of all, we have 1, 2, 3, 4. We have 4 CH bond. Remember, you have to indicate the type of bonding is single bond or double bond. Okay, and then we have to break a CC double bond. So we have 1 CC double bond. And then we also need to break this HCl. Okay, we have a HCl single bond. Okay, so this is bond breaking. We require to do this. Okay, bond forming. Okay, you will have like 1, 2, 3, 4, 5. Okay, you have 5 CH single bond. Okay, you have 1 CC single bond, so 1 CC single bond, and also 1 CCl single bond. So this is bond forming, and this is bond breaking. Okay, so you can see that. Okay, your presentation will be like that. Okay, and then second one, okay, suggest why the reaction is exothermic in terms of bond breaking and bond forming. Okay, so exothermic, that means that, okay, you will have the bond forming releasing process. The energy in bond forming release more than the energy in bond breaking. So you just put this one in a statement form. You say that energy released in bond forming is greater than energy absorbed in bond breaking. So therefore, you have a exothermic reaction in this. Okay, so in the public exam, more or less, it's like this, because I'm afraid, okay, you don't have enough practice. Okay, so you can have a look of the public exam. So in this case, okay, we require you to write down the bond breaking and bond forming process, okay, during a combustion of methane. You know that combustion, it must be an exothermic reaction. So in this case, okay, it would be good if you draw all this into a structural formula. So if you draw like this way, then you will see clearly what kind of bonding you have to overcome, what kind of bonding you're going to form. So the bond breaking process, okay, you have to break 4 CH single bond, 2 OO double bond. And a covalent bond forming, you need to form 2 CO covalent bond and then 4 OH single bond. So that's it. Okay, so not that difficult. Okay, you just have the concept will do. So the summary, okay, we have to know that, okay, the change in enthalpy, that will be the energy change in bond breaking minus energy change in bond forming. Okay, and then in enthalpy level diagram, when you absorb energy, okay, the level goes up. Okay, the level will go up. That means you break the molecules, okay, into atoms. Okay, you absorb energy. Okay, and when you have released energy, it may go down here or go down here. It depends on the stability of the products. So when you have the molecule, that will be the products. Okay, it will go down to different levels. Okay, so this is the last sections. Okay, for this chapter. Okay, time to finish your chapter exercise. That's all for this video. Bye bye.